We are still on indices, and all these questions are what you want to simplify. They are all indices, because as you can see that they are having powers and they are having bases. So the first question here, they said to simplify question A, 16 all over 81 raised to power 3 over 4. B, 16 all over 81 raised to power minus 3 all over 4. And the third one, which is C, 2a raised to power 3 close bracket raised to power 2 multiplied by 6a raised to power 2. D, 27 raised to power 1 over 3 all over 64 raised to power negative 1 all over 6. All these are indices, but like I said, we are moving from the simple to the complex. So we are going to be looking at how to solve each of these indices one after the other, and join me as we go. Solution. A, we have 16 all over 81 raised to power 3 over 4. Now remember, under our root law, I said we can write the root law in form of fraction. We can write our root law in form of fraction. Now, this can be expressed like this. 16 all over 81, then root of 4, quadroot root of 4, then close bracket raised to power 3. That's what this one is saying. Close bracket power of 3. What are we saying here? What does this one mean? It simply means look for a singular number that you are going to multiply in 4 places, which is the quadroot root of 16, and the singular number you are going to multiply in 4 places that will give you 81. So that number that you will multiply, just single number, times this, times this, times this, times this, let's assume is A. Here it is going to be A times A times A times A in 4 places. That will give us 16. And let's assume we have B here. It's going to be B times B times B times B. That will give us 81. Then after we have gotten that, we are now going to raise them to the power of 3. The true numbers that are going to be in form of this fraction, then we raise them to the power of 3. Then we multiply out. So this can be expressed as this, and this can be expressed as this. 16 over 8 close bracket raised to power 3 over 4 can be expressed as quadroot root of what? 16 all over 81 raised to power 3. So let's move on. Let's move on. So 16 all over 81 raised to power 3 all over 4. Let me tell you for free, that is 2. 2 raised to power 4 all over 3 raised to power 4 will give us 16, and this will give us 81. Everything raised to power 3 all over 4. So 2 raised to power 4 will give us 16, and 3 raised to power 4 will give us 81, which is 2 multiplied by 2 times 2 times 2 will give us 2 times 2, 4, times 2, 8, times 2, 16, and 3 multiplied by 3 multiplied by 3 multiplied by 3 in 4 places. 3 times 3 is 9, times 3 is 27, and times 3 will give us 81, as you can see. So we have expressed this in this index form. Now, if you look at it very well, 2 raised to power 4 and 3 raised to power 4, they have something in common, which is what? 4 and 4. So we can factorize by saying 2 raised to power 2 all over 3 raised to power 3 raised to power 4 multiplied by 3 all over 4. We can factorize it out like this. 2 all over 3 close bracket raised to power this 4 that's common to the both of them, then multiply by 3 all over 4, which is the power. Now, if you look at this one very well, this 4 can cancel this 4. So what we are having here left is 2 all over 3 raised to power 3. So which we can express as 2 all over 3 all over 3 all over 3, which will give us 8 all over 27, which is our final answer. Look at it from beginning again. Let me express it. 16 over 81. What is that number that we can multiply in 4 places? That's what they are telling us here. That's the quadroot of 16 and the quadroot of 81. So the single number we can multiply in 4 places to express is 2. So 2 raised to power 4 will give us 16, and 3 raised to power 4 will give us 81. So 4 and 4 are common, so we can factorize this 4 out of this fraction, and that will give us 2 all over 4, 2 all over 3, close bracket, raised to power 4, multiplied by the power that we are having here before, which is 3 over 4. So 3 over 4, 4 can not divide 4. 4 cancel 4, so we are left with 3. So this will give us 2 over 3 raised to power 3. Then we express it, and we arrive at 2 raised to power 3, but that is 2 times 2 in 3 places to give us 8. 3 times 3 in 3 places to give us 27. That's our final answer. Moving on to the next question. Moving on to the next question, which is question B. (16 all over 81 raised to power negative 3 all over 4). Like I said, we can solve this question in 2 ways, but we are going to solve it in the more easier way. I have told you, remember, that when you are having a all over b raised to power any negative sign, let's say 1, this fraction can be inverted. That is, you can change the fraction. The numerator can become the denominator, and the denominator will become the numerator. So which is will give us b all over a. B all over a. So we can write this because of the negative sign. This fraction will what? Will be inverted. It will become a. Instead of a over b, it will become b all over a because of the negative sign. So going by that one, 16 all over 81 raised to power negative 3 over 4 can be expressed as 81 all over 16 raised to power 3 all over 4, which is the same thing as we express this in this format: quadroot of 81 all over 16, everything raised to power 3. So this is what this one is saying, and which means what is that single number that we can multiply in 4 places to give us 81, and the single number we can multiply 4 places to give us 16, like we have done the other one. So this will give us 3 all over 2, everything raised to power 3, which is equal to 3 raised to power 3 all over 2 raised to power 3, which will give us 3 times 3 times 3 in 3 places will give us 27 all over 2 times 2 times 2 in 3 places will give us 8, which is our final answer. That's that of the second example. I hope you are clear with this. Moving on to the third example. (2a raised to power 3 close bracket raised to power 2 multiplied by 6a raised to power 2). Now we can see this. Now let me explain this. In this case, 2a raised to power 3. This a is the one that is having this 3. This 3 only belongs to the a. It doesn't belong to 2. But these 2 belong to both a and 2. These 2 belong to both a and 2. but this a is only having these 3 as its power. It doesn't affect 2, but these two we affect both a and 2. So when we are expressing this, we are going to say 2 raised to power 2 multiplied by a raised to power 3 multiplied by 2 multiplied by 6a square. Look at that. 2 will affect 2 and a raised to power 3 will be affected by this a square. So 2 square multiplied by a raised to power 3 multiplied by that same 2. So that will give us 4 multiplied by a raised to power 6 multiplied by 6 a raised to power 2. Now look at this. We are having a raised to power 6 and we are having a raised to power 2. We can also express that as 4 multiplied by a raised to power 6 multiplied by 6 multiplied by a raised to power 2. So we bring the numbers together. This number will multiply each other. So we are going to have 4 multiplied by 6 multiplied by a raised to power 6 multiplied by a raised to power 2. Remember, they are having the same base, which is AA. So this will give us 4 times 6 will give us 24 multiplied by a raised to power 6 plus 2. Product rule of indices. When you are having the times, you have to add the indices, and that will finally give us 24 a raised to power 8. Final answer. So this is the solution to the question number C that we are simplifying from our example. So as you can see, we express this like this and we follow it step by step like that. So why are we multiplying this? As you can see, the coefficient of a raised to power 6 and the coefficient of a raised to power 2 is 6. We have to separate them and multiply the two of them, but bring out this base because they are having the same base as a. So bring out the base, then add the indices, then multiply them out, then will give us this one. So whenever you are facing any of this kind of challenge in indices, this is how you express them and sum them completely. So the last question on our example here is (27 raised to power 1 all over 3 all over 64 raised to power negative 1 all over 6. They are not having same power here. 27 is having separate power and 64 is having separate power. So we are going to solve them separately. And what this one is telling us here is 27, which is the cube root of 27 all over 1 all over 6 root of 64. Now, what does this one tells us, or what are they asking us to do here? They are asking us to look for that number that we can multiply in 3 places to give us 27, and here they are telling us that we should look for one number that we can multiply in 6 places that will give us 64. In 6 places to give us 64, here in 3 places to give us 27, here in 6 places to give us 64. And very simple, you don't need, without wasting our time, the number here is what? Is 3, and the number here is 1 all over 2. Now, why am I expressing my 64 raised to power negative 1 over 6 like this? You remember that I said a raised to power minus 1 all over 2 can be expressed as 1 all over the root of a. So that is what we are expressing here. Whenever we are having a negative sign with a fraction on it, so this is how we express them. That's how we are having 1 all over 2. So we can further express it as what? 3. If we separate this fraction, all over 1 divided by 1 all over 2. So that will give us 3 all over 1 multiplied by 2 all over 1. So that will give us 2 times 3, 6. 6 divided by 1 give us 6. So that's our final answer. So that's our final answer, and that's where we are going to stop for today. So when next we are going to meet, we are going to be solving other cases on indices. And thank you for joining us. By this time, next time, we are going to be moving on to other cases of indices. If you have not subscribed to our YouTube channel, please try and subscribe and give us a thumb up on this channel if you find our lesson interesting. God bless you till I come your way.